concepts from the physics. So in these sessions we are discussing important from the particular chapter, important concepts from the particular chapter. So you can join in our app. So in detail for each and every concept will be discussed in detail. Myself, Sandhya. Today I would like to discuss the vectors. So I will be helping you to solve the all important solutions. So we are going to discuss the important concepts from that particular chapter as per the schedule. And here you are given with the coupon code. You can use this coupon code if you are buying any course from the Spark Academy app. You can use the coupon code SAN10 and you will get the 10% discount on this coupon. So with this you are, in other way you are supporting me with this, you will be supporting me. So don't forget, if you are buying any course from the Spark Academy, use the coupon code by my name, that is SAN10. Yeah, students, so let us go to our discussion. So today, in today's session, we are going to discuss about a resolution of vectors into components, scalar product of two vectors, vector product of two vectors. These concepts, weightage of the vectors means actually with the help of techniques of vectors, we can solve the questions from motion in a plane, and the vector algebra techniques will be used in work, power, energy at electrostatics. So we use the vector algebra techniques where the physical quantities, in the measurement of physical quantities at these chapters, we can use these techniques. So with the help of, it is a technique that we are using to measure the physical quantity, which are called vectors, at moving charges and magnetism. Charges and magnetism, and at rotatory motion also. So with the help of techniques of vectors, at all these chapters the numericals can be solved. Vectors play such an important role to solve the numericals in the measurement of physical quantities. So today in our session we would like to discuss resolution of vector into components, scalar product of two vectors and vector product of the. So now our concept is resolution of vector into components. Resolution of vector into components. Let us see the diagram here. There is a vector r bar in xy plane which is showing along x and orthogonal vectors along x direction and y direction. So we know that with the coordinate system, orthogonal unit vector, if we are showing that vector along x direction, instead of saying vector along x direction, you can give ax into I cap, and if it is lying along y axis, the unit vector along y axis is j, so you can say ay into j cap. Unit vector along z axis k cap, and this given vector, if it is lying along z axis, we can write az into k cap. So instead of writing any vector which is lying along x axis or y axis or z axis, we can write them a into j cap if it is along y axis, az into k cap if it is along z axis. So to show the vectors with the coordinate system, so we represent with their direction along with their unit vectors. Okay, so like that. For example, if this vector is lying along x and y, I can say vector a bar will be equal to ax into I cap plus ay into j cap plus az into k cap. Now we discuss the resolution of vector into components. So if any vector is showing x axis, you write like ax I cap. If any vector showing along y axis, you can write ay into j cap. If any vector not along x axis, not along y axis, it is not lying along x axis, not along y axis, such vector resolve into its components. Consider such vector r bar which is lying along x and y. So now this vector can be resolved into its components along x direction, along y direction. Okay. So now, we are going to show that vector r bar along x direction, along y direction. So here we are given with that vector making angle theta with the x direction. Now we can write, by following the vector addition, r bar is equal to rx cap, means rx into I cap plus ry into j cap, means this equation r bar can be represented which is lying along x axis. So now rx and ry are the components of r bar. Rx is along x direction, so unit vector is I cap. Ry component is along y direction, its unit vector is j cap. So by following the vector addition, this is the vector into its components, and from the figure we can see Rx is adjacent to the angle. Always remember, a side which which is adjacent to angle, that will be cos component. So we can write Rx is equal to R cos theta, and this component Ry component is opposite to the angle. So we can write Ry is equal to R sin theta. Rx is equal to R cos theta. That component is lying adjacent to the angle. Ry component is opposite to the angle. So we resolve this vector into its components. For example, we just look into here. From the figure, Rx is R cos theta, Ry is R sin theta. Now they are asking, find the magnitude of the vector R bar. It can be obtained by squaring and adding the above equations. So, or you can follow vector addition, resultant magnitude of vector addition, by following that equation also, whereas angle between Rx and Ry is 90 degrees, they being perpendicular to each other. So you can find this magnitude by using R is equal to under root of Rx square plus Ry square plus 2Rx Ry into cos theta, where theta is 90 degrees. So then the magnitude of the vector R bar will be equal to under root of Rx square plus Ry square. And next, if they ask direction of the vector R bar, it can be obtained by dividing the above equations. So, or you can follow how to find the direction of vector by using the parallelogram of vector addition. So there we consider tan theta, which will be equal to y component by x component. Or you can write theta is equal to tan inverse of Ry by Rx. So when a vector resolves into its components, the magnitude of that vector is under root of Rx square plus Ry square. Direction of the vector is tan theta is equal to Ry by Rx. And let us see here, for example, if that vector, the vector R bar, is making angle theta with the vertical. So now this vector, which is lying along x and y plane, it resolves into its components. So along x direction Rx, along y direction Ry. So here we can write R bar is equal to Rx into I cap plus Ry into j cap. But the resultant vector here, this R bar, it is making angle theta with the vertical. In previous diagram we have seen it is making angle theta with the horizontal. So Rx becomes R cos theta, Ry becomes R sin theta. Here, when angle made with the vertical, angle made with the vertical, so always on this note, a side which is adjacent to angle will be cos, a side which is opposite to angle will be sin. Now that vector R bar making angle theta with the vertical, now Rx will be equal to R sin theta, Ry will be equal to R cos theta, because Ry is being adjacent to the angle and Rx is being opposite to the angle. So we must be careful, angle made with the vertical or angle made with the horizontal. As per that, need to give the components of the vector, where Rx and Ry are components of the vector R. Next, our next concept is scalar product of two vectors. The scalar product is also called as scalar or dot product. It is also called as scalar product or dot product. If there are two vectors A bar and B bar having angle theta between them, let me show here vector A bar and another vector B bar having angle between them. Angle between them is theta. Now the dot product of these two vectors can be written as, or scalar product of these two vectors can be written as, A bar dot B bar will be equal to, it is the product of vector A and the component of vector B which is along the direction of vector A, because this vector can resolve into its components. In this direction, B cos theta and opposite to angle B sin theta. Now the vector B resolving into its components, dot product of these two vectors can be written as product of vector A and the component of vector B along the direction of A. So component of vector B along the direction of vector A is B cos theta. So you can write it as AB cos theta. So as by the definition, A bar dot B bar will be equal to AB cos theta. Angle between the vectors, to find angle between them, theta will be equal to cos inverse of A bar dot B bar by AB. We need to take the magnitude of that A and B. So to find the angle between them, it will be equal to cos inverse of A bar dot B bar by magnitude of AB. Next, under the properties of the scalar product, it is very important property. The scalar product of the two vectors will be maximum when cos theta is equal to maximum. That is, theta value is 0, means the vectors are parallel. Means if you are given with parallel vectors, then their dot product is equal to 0. You can apply the property of scalar product, that is, their dot product will be equal to 0. Means angle between them will be equal to 0. So substitute angle 0. So we get A bar dot B bar is equal to AB. That is the maximum value of the scalar product of that two vectors. So A bar dot B bar maximum value is AB. So when vectors are parallel, theta 0, then the maximum product of vectors is equal to A. Next, Next property, scalar product of two vectors will be minimum when cos theta is equal to minimum. Cos theta minimum means it should be 0, means angle between them will be 90. So a bar dot b bar minimum will be equal to 0. So if you are given with a bar is perpendicular to b, if a bar is perpendicular to b bar, then you can apply the property a bar dot b bar is equal to 0. Their dot product will be equal to 0. This property, when vectors are parallel, a bar is parallel to b bar, then a bar dot b bar will be equal to ab. Means if it is given with the coordinate system, you can write like magnitude of a into magnitude of b. Next, and next property of the scalar product, here we are given with in terms of components. The given two vectors are given with the coordinate system ax into I cap plus ay into j cap plus az into k cap dot bx into I cap plus by into j cap plus bz into k cap. So in terms of components, then the dot product, the corresponding components will be minus ay into by plus az into bz. So these are the properties of a scalar product, and we see the examples of physical quantities which are scalar product of the two vectors. So in physics, it is well established, like work done is equal to F bar dot S bar. So here work done is a scalar product of the two vectors. The two vectors are force and displacement. Next, power is equal to dot product of, which is instantaneous power, dot product of force and velocity. Next, magnetic flux. So here we are given with flux through the area, amount of flux through the area, d phi is equal to b bar dot ds bar, where b bar is the magnetic field and ds bar is the aerial vector. So in the measurement of magnetic flux, which is the dot product of these two vectors, magnetic field and aerial vector, so we apply the properties of dot product in the measurement of these scalar quantities. Next, potential energy. In the calculation of potential energy also, we can follow the dot product properties of dot product. Potential energy of a dipole we represent with the symbol U. Here you can see potential energy due to electric field or dipole moment in the electric field. Then the potential energy of the dipole will be equal to minus P bar dot E bar, where P bar is the dipole moment, E is the electric field. Next, potential energy of a dipole in the magnetic field, B represents magnetic field, will be equal to, it is the dot product of magnetic moment, where M is magnetic moment and B bar is magnetic field. So in the calculation of these scalar quantities, we can follow the properties of scalar product or dot product. And keep in mind, dot product of any two vectors gives the scalar quantity. So you can say work done is scalar. Similarly, power is a scalar. Magnetic flux is a scalar quantity. Potential energy of a dipole is also a scalar quantity. It is given with dot product of two vectors. And observe the diagrams here. Here we are given with vector A bar and vector B bar, which is having angle between them. So the scalar product of these two vectors, we can write A bar dot B bar is equal to AB cos theta. Next, in the next diagram, you can observe here vector A bar and vector B bar. Now we have drawn a perpendicular onto A. Now B cos theta is lying along the direction of vector A. Now this B cos theta is the projection of B onto A. So if they are asking, find the, can add this important point also, projection of vector B along A bar. Means you need to find B cos theta. So that is, it is equal to projection of vector B along A bar, means you have to find A bar dot B bar by magnitude of A. If we are given with the coordinate system, we need to take A bar dot B bar by magnitude of A. So B cos theta is the projection of B onto A. And next diagram, now there is an angle between vector A bar and B bar. Draw a perpendicular onto A, onto B, vector B. Now this is the perpendicular drawn from vector A to B. Now this is the A cos theta component, which will be the projection of A onto B. Now we can calculate. Now you have to find A cos theta, projection of vector A bar along B is equal to, so keep in mind these 2 points in the properties of dot product. Projection of vector B means you need to find B cos theta, that is equal to A bar dot B bar by magnitude of A. Projection of vector A bar along B bar is A cos theta, that is equal to A bar dot B bar by magnitude of A. Let me add one more point in the properties of dot product. In case of unit vectors, we know that I, J, K are the unit vectors which lies along X, Y, Z axis, which shows the direction along X, Y and Z. If we take I dot I, j dot j, k dot k will be equal to 1. So in case of unit vectors, the dot product I dot I, j dot j, k dot k will be equal to 1. If we are taking I dot j, j dot k, k dot I will be equal to 0, because I dot j means these two will be perpendicular to each other, or j dot k, these two will be perpendicular to each other. When theta 90, the dot product will be equal to 0. So in case of unit vectors, the vectors which are parallel to each other, their dot product is maximum. So I dot I 1, similarly j dot j, k dot k. If we take I dot j, j dot k or k dot I, which are being perpendicular to each other, their dot product will be 0. Our next concept is vector product of two vectors. Vector product or cross product. It is also called as cross product. So here vector product or cross product, we are given with the two vectors a bar and b bar. Then their vector product can be written as a bar cross b bar. It is a vector c bar. So you can see here c bar is equal to a bar cross b bar can be written as ab sine theta into n cap, which indicates the unit vector. So see here, we are given with two vectors, vector A which is along horizontal, another vector B which is making theta with the horizontal. Now angle between them is theta. Now vector B resolve into its components. B cos theta, opposite side to angle is B sin theta. Now A bar cross B bar, the vector product of these two vectors can be written as, it is the product of magnitude of vector A and the component of vector B which is perpendicular to the vector A. Now B sin theta is perpendicular to A, so we can write AB sin theta, because when two vectors are perpendicular to each other, then a cross product will be maximum. So A bar cross B bar can be written as AB sin theta. Let us see the properties of vector product. The vector product of two vectors will be maximum when sin theta is equal to maximum. Sin theta is maximum for 90 degrees angle. So when theta 90 means the vectors are being perpendicular to each other. So now A bar and B sin theta are perpendicular. So now A bar cross B bar is being equal to AB sin theta, which is the 9 sin. So the vector product of two non-zero vectors will be minimum when sin theta is minimum. Sin theta is minimum for theta equal to 0 or 180. And the next property, in terms of components, cross product of two vectors can be calculated by taking its determinant value. So you can write here A bar cross B bar is equal to determinant of, we write I, j, k components of two vectors. So components of vector A is Ax, Ay, Az, and components of vector B is Bx, By, Bj. And the determinant value will be equal to, first we take, we neglect this column and this row, and the cross multiplication, difference in the cross multiplication will be the component of I. So it will be Ay, Bz minus Az, By, plus and the sign will be, actually here we need to give the alternate sign while taking the determinant. I component with plus sign, j component with minus sign, k component with plus sign, so on that way, minus j into. Now this time this column and this row, now you need to take Ax into Bj. Yeah, so they took the common minus, so it becomes plus 1. Ax into Bj minus Az into Bx. While taking common minus, it becomes a plus j into Az Bx minus Ax Bj plus. Now components of k. Now this column you need to take cross multiplication and the difference between them. Ax By minus Ay Bx. So in terms of components, A bar cross B bar will be the determinant value. So this way we need to find the cross product of that two vectors. And yes, let me give a few more points here. In case of unit vectors means I, j, k are the unit vectors. If we take I cross I or j cross j or k cross k, their product will be 0, because I cross I, these two will be parallel to each other. So angle will be 0 or 180, that way. In clockwise or anti-clockwise we can consider. So for angle 0 or 180, the vector product of that two non-zero vectors will be minimum. So minimum is 0. If we take I cross j, j cross k, let me give you, I cross j will be equal to k cap. Next, j cross k will be equal to I cap. Next, of course their magnitude is equal to 1. K cross I will be equal to j cap. If we are taking j cross I in anti-clockwise direction, then it will be minus k cap. K cross j, it will be minus I cap. I cross k, will be equal to minus j cap. So if the two vectors are perpendicular, their cross product will be maximum. I cross j is equal to k cap, j cross k is equal to I cap, k cross I will be equal to j cap. Means it shows in the direction. Its magnitude, whereas it is a unit vector, will be equal to that. If you take in opposite direction, we get negative direction. J cross I become minus, k cross j becomes minus I cross k becomes minus j. In physics, let us see the examples of cross product of two vectors, which is a vector quantity. So these are the quantities which are established in physics. Torque, which is the cross product of r bar and f bar. R bar is distance and f bar is force. Angular momentum, L bar is equal to r bar cross p bar. Linear velocity, v bar is equal to omega bar cross r bar. And force on a charged particle moving with velocity v in a magnetic field is F bar is equal to q into v bar cross b bar. Torque on a dipole in a field which is in the electric field, it is cross product of P bar cross E bar. Torque experienced by a dipole in the magnetic field, which is the cross product of M bar cross B bar, where M bar is magnetic moment, B bar is magnetic field. Here electric P bar is electric dipole moment and E bar is the electric field. So in the measurement of these vector quantities, we can follow the properties of cross product. And let us see a few more important points in the properties of cross product. So to find in terms of coordinates, we have seen how to find the cross product of two vectors. We need to take the determinant. For example, if two vectors A bar and B bar are parallel, then you can say A bar cross B bar will be equal to 0, or you can equate the ratio of the components. So along x, y, z, their components, you can equate their ratio of the components, because their ratio of the components will be equal to constant. So ax by bx will be equal to ay by by. That will be equal to az by bz. which is equal to constant. And next point, unit vector n cap, here unit vector is n cap, is normal to A bar and B bar. Is, if a unit vector is being normal to both A bar and B bar, then how to calculate that unit vector means, then n cap will be equal to A bar cross B bar by magnitude of A bar cross B bar. So keep in mind these points in the properties of vector product or cross product. So the cross product of any two vectors gives vector quantity. So here displacement and force are the two vectors. Their cross product is a torque, which is a vector quantity. Now all these torque, angular momentum, velocity, all are vector quantities. Students, you can download the Spark Academy app for get the great discounts on our course. About this app, there is a free study material and free tests will be conducted, and free handwritten notes is available, free study material and previous year's questions included, and free mock tests will be conducted. So if you are buying any course from the Spark Academy app, here in detail they given long-term courses for 2020 to 23. So you can experience the high quality teaching, and for JEE mains, NEET, Eamcet and IIT foundations. So here are the timings given for short time coaching, regular coaching, and crash course we are going to conduct soon. So online coaching is available. Students, don't forget to enter a coupon code if you are buying any course from the Spark Academy app. By using this code SAN10, by using this code you will get the 20% discount on that particular course, and you will be supported by using this code. So what you have to enter a coupon code, but this code is by my name, SAN10. So you will be having daily and on-demand live sessions. Our methodology in teaching, we start with the basic concepts, shortcut methods, all model questions, exercise questions, previous year's questions, and chapter-wise tests will be conducted. Weekend tests, every weekend test regarding that concept discussion, and test analysis will be given in that week. And this is the information about a classroom and online coaching, about the material and the tests. Students, now let us solve few previous year's questions. If a vector 2i plus 3j plus 8k is perpendicular to the vector 4j minus 4i plus alpha k, then the value of alpha is, they are saying that two vectors are perpendicular to each other. If any two vectors are perpendicular to each other, their dot product, let us say given vectors are a bar, b bar. So their dot product will be equal to 0. So you can use this property when a bar is being perpendicular to b bar, the dot product will be equal to 0. So take the dot product of these two, 2i plus 3j plus 8k dot 4j minus 4i plus alpha k will be equal to 0. So we can write it as, it is given like 4j minus 4i. So I components can be multiplied. It is minus 8i. I dot I will be equal to 1. So then the dot product we get like minus 8. Next, 3 into 4. Corresponding coordinates will be multiplied here. And their resultant will be added. 3 fours will be 12. Plus 8 into alpha plus 8 alpha will be equal to 0. Then minus 8 plus 12 is plus 4 plus 8 alpha is equal to 0. From this we can write 8 alpha is equal to minus 4, alpha is equal to minus 4 by 8, which is equal to minus 1 by 2. So we have used the property of dot product or scalar product. When two vectors are perpendicular to each other, their dot product will be equal to 0. And we have find the value of constant alpha. Next, if two vectors 2i plus 3j minus k and minus 4i minus 6j minus 3k are parallel to each other. So here we can use the property of the vector product, because the given two vectors, and we need to find the constant value, and the given two vectors are parallel to each other, then their cross product will be equal to 0 when a bar is parallel to b bar, or we can use ratio of their components remains constant, means axy bx will be equal to ay by by will be equal to az by bz. It remains constant. So now we follow this property to find the unknown value lambda. So I can write ax component of first vector, ax x component is 2 by minus 4 is equal to 3 by minus 6 is equal to minus 1 by minus lambda is equal to constant. So it is 2i plus 3j minus k and minus 4i minus 6j minus lambda. So you can equate with any of this ratio, then 1 by lambda is equal to 1 by 2. Actually we are getting minus also, so you just write its magnitude, then lambda value is equal to 2. Actually we are getting with minus, its magnitude constant value, only value we are representing, that is 2. So here we are using property of the vector product or cross product. A particle moves from position 3i plus 2j minus 6k to 14i plus 13j plus 9k due to a uniform force of 4i plus j plus 3k newtons. The displacement in meters, then work done will be. So the given displacement is in meters, then what is the work done? Work done is the dot product of two vectors and it is a scalar quantity. Here force vector is given and displacement is need to find by changing its position, because displacement is equal to change in position, like R2 minus R1. So you can take this is R1 initial position, R2 final position. Then the displacement will be 14 minus 3, so it is 11i, 13 minus 2 plus 11j, 9 minus of minus 6 plus 15k. This is the displacement. Now find the work done by following the dot product. Force is given as 4i plus j plus 3k dot 11i plus 11j plus 15k. So the corresponding I dot I means the corresponding components will be multiplied. Then their product will be equal to 1, because I dot I equal to 1, j dot j equal to 1, k dot k equal to 1. But I dot j, I dot k, their values becomes 0. So 44, 11 plus 11 plus 45. If you add this, we get the work done as 100 joules. Next problem is about the cross product of vectors or vector product of the vectors. A bar is equal to 3i plus j plus 2k, b bar is equal to 2i minus 2j plus 4k. They are asking magnitude of a bar cross b bar. So we take the determinant. A bar cross b bar will be equal to I, j, k components we have to write. Ax, ay, aj, bx, by, bj. Then here a bar cross b bar will be equal to I, j, k. I, j, k components of vector A 3, 1, 2. I, j, k components of vector B 2, minus 2, 4. So it's a determinant value I into 4 plus 4 minus j into 12 minus 4 plus k into minus 6 minus 2. It becomes minus 8. Then the magnitude of their cross product will be equal to under root of, means under root of I square of the component of I, square of the component of j and square of the component of k. So here 4 plus 4 means 8 whole square plus 12 minus 4, 8. Here also 8 whole square will come. Here minus 8 whole square. It will be equal to, taking common 8 square, root square cancel, answer will be 8 root 3. So to find the magnitude of their cross product, we are taking in terms of coordinate system, we are following the determinant. So students, here I given you few questions. You can try these questions and you can drop your message in the chat. So try the questions. Find the angle between the vectors I cap, I bar plus j bar and j bar plus k bar. To find the angle between them, let us take a bar and b bar. Cos theta is equal to a bar dot b bar by magnitude of a bar dot b bar. Means you need to take a bar dot b bar by magnitude of a and magnitude of b. That way. And next question, we are given with the force and the acting at the point. We need to find the torque acting. So we know that torque is the cross product of r bar plus f bar. So take the determinant for this. So students, try these questions and leave your drop your message in the chats. So this is the required discussion for today's session. Really important concept discussions. So you can join with us for regular updates. Thank you, students.